Today, we get a new property. It's when you take a power to a power, the power of a power. Before we hit that, I want to review real quick what we've learned so far. The important thing here is to realize sometimes the powers don't change, sometimes you add the powers, and as you'll see, sometimes you multiply the powers. So you've really got to keep it straight what operation you're doing and what the steps are. The first thing we did was add and subtract polynomials. And when you add and subtract them, you add the coefficients on like terms, and the powers never change. 3x to the 7th plus 2x to the 7th. The coefficients are 3 and 2. Add them. 3 plus 2 is 5. That's 5x to the 7th. The powers never change when you add. Negative 4pq and minus 3pq. Negative 4pq, you're taking away 4 of them, and then you're going to take away 3 more of them, which means you're going to take away 7 pq's. This is one thing. It's some number. Negative 4 minus 3 is negative 7 of that number. 8a squared b minus 10a squared b. 8 minus 10 is negative 2. The powers never change. Negative 2a squared b. And the last one, negative 5xyz minus negative 2xyz. When you minus a negative, you add the opposite. These signs change. Just the double negative makes a positive. It's really then negative 5xyz plus positive 2xyz. Negative 5 plus 2 is negative 3xyz. Multiplying. When you multiply polynomials, you multiply the coefficients and add the powers on like bases. Coefficients are 6 and 3. This is times everywhere. This is 6x, which is 6 times x, times 3x, which is 3 times x. I can multiply in any order and I get the same answer. 6 times 3 is 18. Multiply the coefficients, add the powers on like bases. X to the first times x to the first is x to the second. Below that, 8 times negative 3 is negative 24. Notice the negative always goes in front of the number. X squared times x to the 4th. I've got 2 of them right here and 4 right here. Altogether, there are 6 x's multiplied. Negative 2a cubed b squared times negative 4ab cubed. Negative 2 times negative 4 is positive 8. A cubed times a to the first is a to the 4th. There are 4 a's multiplied. And b squared times b cubed is b to the 5th. And the last one here, 7 times 3, well, that's 21. A to the 4th times a to the 1st is a to the 5th. And b to the 1st times b to the 2nd is b cubed. And we get to our new property. This is the power of a power property. Notice how we have x squared cubed, x cubed to the 4th, and x to the 4th to the 3rd power. We want to avoid writing this out 3 times, or here 4 times, or here 3 times. In order to do that, we need to figure out what the shortcut is. What can we do to make this quicker? But writing it out like this will help us understand what the property is. Look at x squared cubed. X squared times x squared times x squared. There are 3 of those things. Notice that you're multiplying. Hey, we just did multiplication. When you multiply the coefficients, which are 1 times 1 times 1, which is 1, and you add the powers on like bases. There are 2 x's here, x times x. There are 2 more here, x times x, and 2 more here. Altogether, there are 6 of them. 1 x to the 6th. And we don't need to put that 1 1x to the 6th and x to the 6th are the same thing. 2x cubed to the 4th power. Notice it's 2 times 2 times 2 times 2, which is 16. And we have 3x's, 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 and 3x's. Add all those up because we're multiplying. When we multiply, we add our powers. And 3 plus 3 plus 3 plus 3 is 12. That's x to the 12th. And the last one, 5 times 5 times 5 is 125. There are 4x's here, 4x's here, and 4x's here. That would be x to the 12th again. Now, what's the shortcut? Let's observe the shortcut. Notice that we have an x to the 6th right here. Hey, 2 and 3, 6. Notice that here we have an x to the 12th. 3 and 4, that's 12. Oh, and here we have another 12, and it was 4 and 3. It appears then that you multiply your powers. But there's a common mistake here. Students always want to put, and this is wrong, 3x to the 6th here. What they forget is that there's a 1 in front of that, and 1 to the 3rd power is 1 times 1 times 1, which is 1. Don't put a 3 in front of that. Notice that we take 2 right here to the 4th power to get 16. 2 times 2 times 2 times 2. And notice here that we take 5 to the 3rd power, 1, 2, 3, to get 125. So what we do then is take the coefficient to the power and multiply our exponents. When do we do this? You have to know when, or you're going to be a mess. When you have a power of a power, when you have a power to a power, that's when you multiply your exponents. When you have a power of a power, take the coefficient to the power and multiply the exponents. Let's take a look at some examples. This is 2 to the 1st, and we multiply our exponents. If you remember that, 1 times 5 is 5. This becomes 2 to the 5th. 2 to the 5th is 2 times 2 times 2 times 2. You can do that on a calculator. It ends up being 32. And then we have a power to a power. We multiply our exponents. X to the 10th. This is negative 3 to the 1st. 1 times 3 is 3. It'll be negative 3 cubed. Negative 3 times negative 3 times negative 3. Notice when I take negative 3 times negative 3 times negative 3, I guess I'll use parentheses for multiply. 2 negatives make a positive. There's going to be 1 left over. This is going to be negative. 3 times 3 times 3 is 27. And again, we have a power on a power. We multiply our exponents. X to the 12th. Negative 2 to the 4th power is negative 2 times negative 2 times negative 2, 4 times. Every pair make a positive. A negative times a negative is a positive. This will be positive. If this number is even and you take a negative to an even power, you'll always get a positive because every pair cancel out. 2 to the 4th power is 16. And x to the 5th to the 4th power, this is the power of a power, x to the 20th. Multiply your powers. For this next example, remember there's a 1 in front, and 1 cubed is not 3. It's 1 times 1 times 1, which is 1. This is 1. I don't have to put that 1. X to the 6th, that's 2 times 3. And y to the 12th, That's 4 times 3. 2x y cubed to the fourth. 2 to the fourth power is 16. 2 times 2 times 2 times 2. This is x to the first to the fourth power. Multiply your exponents. 1 times 4 is 4. X to the fourth. And y cubed to the fourth is y to the 12th. And the last example, negative 5 squared is negative 5 times negative 5. That's positive 25. X to the 14th, y to the 4th. At this point, hopefully you're realizing that there's some potential to get confused here. Because when you add and subtract, the powers never change. When you multiply, you add your powers. And when you have a power of a power, or power to a power, you multiply your powers. That's three different things going on. It's easy to get confused. You've got to pay attention to whether you're adding or subtracting. Remember, the powers don't change. Negative 8 plus 3, you add the coefficients, negative 5, x squared, y cubed. Powers never change when you add and subtract. When you're multiplying, you multiply the coefficients. 6 times negative 3 is negative 18, and you add the powers on like bases. X to the fourth times x squared is x to the sixth. Y to the fifth times y to the first is y to the sixth. And the one we just learned, this is not 3 times 4. That's a coefficient. It's not an exponent. You only multiply exponents. This is 3 to the first power. 1 times 4 is 4. It's going to become 3 to the fourth. Take the coefficient to the power. 3 to the fourth, I believe, is 3 times 3 times 3, 4 times, I think it's 81. X squared to the fourth power is x to the eighth. And y cubed to the fourth power is y to the 12th. When you have a power of a power, you multiply your exponents. The rest of this video is questions from your assignment. If you have a problem that you don't understand on your assignment, fast forward and find that example you're looking for, because I go over every type of question on this assignment. Question 1, the power rule. This is when you have a power to a power. You multiply your exponents. Product means multiply. Notice that x to the nth power to the mth power is x to the n times m. So the first one, I'm going to take r times x. That's just rx. For the second one, w to the 7th to the 8th power. That's w, multiply your powers, to the 56th. Again, I'm going to point out, when you take w7 to the 8th, the common error, but this is not equal. Students always want to say 8w to the 7th, but that is wrong because this is 1 in front, and 1 to the 8th power is 1 times 1 times 1 times 1, 8 times, which is 1. There's a 1 in front of this, and I don't need to put that there. 3 to the 5th to the 3rd power is 3 to the 15th. You multiply your powers. Notice that the w didn't change in your answer. It was still a w. The 3 won't change. It's still a 3. Compare that to the product rule when we're multiplying. This is a different situation. When you're multiplying, you add your powers on like bases. A 2 is a like base. They both have a base of 2. This is 2 to the 6th power then, which you could work out if you like. 2 times 2 times 2, 6 times is 64. It'll accept either one of these answers. Question 2, you have a power of a power. Multiply your exponents. This is v to 10 times 11 is 110. Notice the number in front is still a 1 because 1 to the 11th power is 1 times 1 times 1, 11 times. It's going to be 1. Question 4. We're going to take negative 5 to the second power, which is negative 5 times negative 5. Notice that that's positive 25. 25 x to the, when we have a power on a power, an exponent on an exponent, we multiply our powers. That's x to the 14th. Notice again, students will always want to go negative 5 times 2 and say that's negative 10, and they'll try to put that right in front of the x, but that's wrong. You don't multiply the coefficient times the exponent. You take the coefficient to the power of the exponent, and negative 5 squared was 25. Question 5. Negative 2z to the 4th squared. We're going to take negative 2 to the power of 2. Negative 2 squared is negative 2 times negative 2, which is positive 4. That's 4, and when we have an exponent on an exponent, a power of a power, we multiply our powers, z to the 8th. Question 6. Negative 5y to the 9th to the 4th power. That's negative 5 to the 4th power, which you don't need to write this out. You can do it on a calculator, but make sure you use parentheses. Keep in mind there's a difference between these two. With the parentheses, notice it's in parentheses, it's negative 5 times negative 5 4 times, and every pair make a positive, positive, positive. This is positive. See, 5 times 5 is 25, times 5 is 125, and 5 times 125 is 625. This is 625. If you write it like this and punch it in the calculator without the parentheses, this means the opposite of 5 to the 4th, which is actually negative 125, which would be wrong. That's not what you want. You got to have parentheses. So notice they're different. 625 y to the, we multiply our powers. 4 times 9 is 36. Question 7. Negative 5 cubed is negative 5 to the 3rd power, which means you're going to have 3 negatives. A pair makes a positive, and there's going to be 1 left over, so it's going to be negative. And 5 times 5 times 5 is 125, and a power on a power, we multiply our powers. This is v to the 12th. In question 8, we're going to take negative 2 to the 4th power. Again, you need parentheses. Negative 2 4 times. And you don't have to write this out. I'm just doing it so I can show you that here a pair makes a positive, here a pair makes a positive. This is going to be positive, and 2 to the 4th is 16. 16. We're taking x to the 6th to the 4th power. We have a power on a power. We multiply our powers, x to the 24th. And w cubed to the 4th power is w to the 12th. In question 9, you're going to take negative 4 to the 4th power, which means you're going to have 4 negative 4s. Every pair makes a positive. So this will be positive. And we'll get out the old calculator. 4 to the 4th power is 256. 256 h, and we have a power and a power. We multiply. 9 times 4 is 36. And b to the 5th to the 4th power will be b to the 20th. In question 12, we're going to take 3 and cube it. 3 cubed is 9 times 3, it's 27. 27, and since you have an exponent on an exponent, we multiply. 5 times 3 is 15, so this is m to the 15th. And x becomes 6 times 3 is 18. Question 13 is a little confusing because you're actually doing two operations. You are taking this times this, and you have to remember the old PEMDAS. And it's been a while since we talked about that. But parentheses, exponents. You have to do your exponents before you multiply because this exponent only affects this thing right here. This becomes 4y squared times, and now I need to square everything. I'm going to take 4 to the first and square it. That's 4 times 4, which is 16. And y squared and square it, and this is a power on a power. It's 2 times 2. Not 2 plus 2. Those happen to be the same thing, but keep in mind you're multiplying your powers when you have a power on a power. And 2 times 2 is 4, y to the fourth. And now you've got a completely different operation. You're just doing plain old multiplying. And when you multiply the coefficients. 4 times 16 is 64. And you add the powers on like bases. Here you have 2 y's. Here you have 4 y's. Altogether, there are 6 y's multiplied. 64 y to the sixth. Students take a question like this and they always want to think, oh, it's different. It's a fraction. It's got to be a lot harder. But it's not. Of course, you could do it this way. You could say, oh, that's x to the fourth over y to the sixth times x to the fourth over y to the sixth times 3 of them, x to the fourth over y to the sixth, 3 of them because it's cubed. And x to the fourth times x to the fourth times x to the fourth, you're multiplying, you add your powers, is x to the 12th. Y to the sixth times y to the sixth times y to the sixth, straight across, that's y to the, you're adding your powers because you're multiplying. That's 18. And this is your answer. But if you did it this way, you're doing a lot of extra work, right? This is a power on a power. You multiply your powers. 4 times 3 makes that x to the 12th. And down below, again, it's a power on a power. It's y to the 6th cubed, which is y to the 18th. It's no different. You multiply your powers when you have a power on a power. Let's also point out that there's a 1 in front of each of these variables. And 1 to the third power is 1, and I don't need to put a 1 in front of my variables. Question 17. We're cubing everything inside. We'll take the 3 and cube it. That's 3 times 3 times 3, which is 27. We have a power on a power. That's when we multiply our powers. A to the 6th. Down below, we're doing the same thing. We're cubing everything. We're going to cube b to the 6th, and it's a power on a power. That's b to the 18th. And c squared cubed is c to the 6th. Your last example is to help you remember the 3 rules. When you're multiplying, you add your powers. This is v to the 14th. There's 7 v's here multiplied, 7 here. Altogether, there are 14 multiplied. And a reminder that there's 1 times 1 in front. And you can put a 1 in front of that, but it's completely unnecessary because it's there whether you put it or not. The second one is what we just learned. There's a 1 in front of this, and 1 to the 7th power is 1 times 1, 7 times, which is 1. I don't need to put a 1. A power on a power, you multiply your powers, that's 49, 7 times 7. And again, you can put a 1 in front, but you don't need to. And here you're adding. When you're adding, the powers don't change. 1v to the 7th plus 1v to the 7th is 2v to the 7th.